Welcome. Today we're going to explore directed graphs, and specifically what we want to do is develop an algorithm that'll find the shortest cycle in a directed graph, and then we're going to implement it. So first let's just recall what a directed graph is. So in an undirected graph, edges go in both directions. In a directed graph, they're unidirectional. So we have a directed graph in front of us. And so our goal is to find the shortest cycle that's in this graph. And recall that a cycle is basically a set of nodes or vertices with edges connecting them such that you come back to where you started, right? And there's a definition there, a non-empty path with only one set of repeated vertices, the first and last vertices in the path. So find a couple cycles in here. There's quite a number. We'll just show three. So the first one, you just follow around. You follow the arrows all the way around. So we can start any node, and any of those vertices could be the beginning or end of the cycle. The next one, perhaps you could talk about this shorter cycle here. And then finally, 3, 5, 8, 7, 3 coming back again. And there are more cycles than we listed. But what we want to do is write an algorithm to find the shortest cycle in this graph. So how could we do that? So the process is going to be almost like finding the largest element or the smallest element in the array. We're going to create an outer loop variable or outer variable to keep track of what's the shortest thing we found so far. And then we're going to perform a BFS starting for every vertex of the graph. So again, just like find the shortest thing in the smallest thing in an array or the largest thing in the array, we're going to go through every element of the graph vertex by vertex. So we're going to do a BFS from each vertex in the graph. After each BFS, we're going to check if the source vertex was part of a cycle, and if it was, what was the length of that cycle? And if it was shorter than the shortest we've found so far, then we'll replace the value in that shortest variable. And then since BFS will always find a cycle of minimal length from a given source, since it searches out breadth first rather than depth first, so it will find all cycles of length 3 before it finds any cycles of length 4 and so forth. That doesn't mean it will necessarily find the same length 3 cycle. If there are two length 3 cycles containing the same source, either of those could be determined to be the cycle. So we don't care which cycle we get, we just want to know the length of the shortest cycle, and this will work with breadth first. So let's go ahead and implement it. Let's jump over to IntelliJ. So in IntelliJ, we're going to start with a file that they have, the breadth first directed paths. So you can make a copy of that and then bring that up into your source, and we'll rename it. And so let's call it shortest directed cycle. And going into this, we're just going to, we're going to be able to follow their code pretty closely. And beginning at the top, we're going to need to create a new variable to keep track of what's the shortest one we found so far. So private int shortest cycle length, and for now we will set it to infinity. So they have a constant that we can use. So we haven't found the shortest one yet, so the shortest one is infinity at this point. Otherwise, these are the same variables we've done before: marked, edge to, and distance, for keeping track of as we traverse the graph. Okay, coming down to our constructor. So again, the constructor takes a digraph, a directed graph, and it kind of builds it out. And so we're going to create our 3 arrays and of the correct size. And then he sets the distance to every node, every vertex, to infinity. Well, we're going to need to do a little bit more here, because this is where we're going to make most of our changes. So after this edge 2, the idea in our constructor is we don't want to just do a single breadth first search. So this is just doing a breadth first search from the given source. We want to do a breadth first search from any source, from every source. Actually, let's get rid of this int s. And then let's create a for loop. for s. So for int s gets 0, and then s less than v dot g dot v, and then s plus plus. So we want to go from every single source, and now we can take basically what they have here and put it in. And then from every single source, we're going to need to reinitialize all of these arrays. So they're initializing distance to infinity, but let's initialize also marked to false, since we'll say we haven't visited yet. And let's say edge 2 goes to 0. So just reinitialize it back because we're going to reuse the same data structure several times. We don't need the validate. We're sure that the validate's correct because we're sure the source is fine because we are controlling the source. We need to validate when we take it in as a parameter. Okay, so after BFS completes, we want to check, was this source actually part of a cycle? And was that cycle the shortest cycle we've seen so far? So we're going to first check what the distance to the source was. And inside BFS, we initialize that to 0. So we're going to say, okay, if it's not still 0, it means we came back to it. So we'll see that we set it to 0 once we get in there. And then we're going to say, okay, and if it's shorter than the shortest length that we've seen so far, go ahead and set the shortest cycle length. So again, this looks very similar to like find the largest number in an array. And that's it. And we can close all these curlies. And we're good. Okay, so let's go down. There's an extra constructor here. Let's get rid of that constructor. We don't need that. Okay, so now in the BFS, we just need to make a couple changes here. Okay, so here's where we're setting the distance to the source to 0. One thing we want to do is we don't want to mark the source, because if we mark the source, then down below we'll never try to come back to it. And so we want to be able to come back to the source so it can be included in the cycle. So let's get rid of this marked source equals true. And then down here, the only other change we need to make is, well, if we ever get back to source, once we get back to source, we found the shortest cycle. So we're done, we can exit. So we can say, okay, if W equals S. So if the current node that we're traversing to is the source, then we've hit it. We don't necessarily need to do this here. We could do the full BFS traversal, but there's no need to, because once we've actually set the distance to the source, we're all set. So we're done with that. So now let's just go down to where we're running it. And so again, we can get rid of this second BFS. So going down to main, the first thing we can do is get rid of this source parameter, since we're going to do a BFS from all sources. And then we don't need what they're printing here, because we're going to change the purpose of what we're doing. And then finally here, we're just going to say, okay, if we found shortest path, if we found a cycle, what's the shortest cycle? So if it equals infinity, that we didn't find one, and we can say, hey, this is acyclic. There's no cycle in here. Otherwise, we found a cycle, and we can print out its length. And perfect. So let's go ahead and try to run this. But before we run it, you're going to need to grab some data. There is a directed cycles that you're going to want to grab. So go ahead and grab that file from code from class. And then let's run this guy. And the first time you run it, as usual, you're going to get an error. So I do get an error. And so let's go up to Run, Edit Configurations, and we'll add the directed cycles in. So that's going to be in Data, U10, and then directed cycles. Okay, so go ahead and hit OK. And now run it again. And this time it prints out that we have a cycle length of 4. And this is all well and good. Let's do one more thing. I want to know what the cycle is that was found. So we're going to need to add an extra variable up at the top. We're going to create a stack. Actually, we'll create an iterable. We'll use a stack to fill it later. So let's create an iterable. It will actually be a stack, but we don't know that at this point. Okay, so the idea now is whenever we find that this is the shortest cycle, we're going to want to fill the shortest cycle. So we want to get the cycle path, starting from S, of course. So the idea is whenever we find a shortest cycle, we want to replace this iterable with the path that is the cycle. And then come down, let's create a new method. Okay, so this is going to get a cycle path from vertex V. We could always validate V, make sure it's good. And then, okay, so the idea is, well, first of all, we're going to just put another sanity check here. Let's make sure that there's a path to the vertex we're trying to go to. Okay, so our iterable is going to be a stack. Because the idea is we're going to traverse the path in one direction, but the path was actually represented in the other direction. The path is kind of inverted because every node that we visit points back to the node that we came from. So we want to now unwrap that, unroll it in the opposite direction. So the idea is we're starting from the source, and let's push that onto the stack. And then we're going to kind of go backwards along the path that we followed to get to the source. So we're going to say, okay, where did we come from to get back to the source? What was the vertex right before the source? And we're going to keep doing this. So we're going to use a do while until we get back to the source. So once we get back to the source, we're done. And then just each time we walk along the path, we'll push that element onto the stack. And then we're going to just, again, get the edge too. So now we're going to say, okay, how did we get to X? Well, let's get the edge that we came along. And this will continue. We're pushing this onto the stack. At the very end, we're going to push the source back onto the stack again. So we ended up where we started. And then we can return this path. And so at this point, we've found the path that the cycle followed. So now if we go down into our main, when we have a shorter cycle, so now we can just do a for loop in here. So like for integer v in the shortest cycle. And we can just kind of print out the elements. And we can just say, okay, system out print. And we can just do v with a little space. And right before that, we can just kind of give this a little header. So the shortest path cycle is, where it's a shortest cycle is. And so this will show what the shortest cycle is. So let's go ahead and run this one more time. And so now it will show me, okay, the shortest cycle is length 4, and the shortest cycle starts at 3, goes to 5, 8, 7, and then back to 3. Perfect. Hopefully this made sense, and enjoy the rest of your day.